All right, welcome everybody. So today's exciting topic is going to be on something that's called captive portals. And you've probably encountered one of these before and just didn't realize that's what it's called. I know for sure Dollar General uses them. Several of the hospitals I've been to use them. Several of the hotels we've been to use them. So what a captive portal is usually they do it on a router, but that requires some setup. So we're running this program on an ESP32 S3 microcontroller board, and the board is acting like a Wi-Fi router. I believe that's called station mode. No, it's access point mode. Yeah, it's acting like a Wi-Fi router. So if we connect to it, thinking that it might have an internet connection, here's what. Oh, it's gonna be hateful. All right, all right. Here's what will happen. Oh, oh wait. Ah ha ha. Yeah, it helps if I rerun the program because I actually messed with the board. Um, so I got some LEDs going on the board that y'all can't see, but right now the board is lit up red, and we don't have any credentials file. There's an access point started, a captive portal, ooh, a DNS hijack, and a web server started. All right, so let's see what this is about. This is what happens when you click on a captive portal. And I actually do have a password on this, but I've already connected to it during testing, so it's saved. And sometimes this will show connection, like right here it says connected and secured. Sometimes it'll say no access. Like it'll probably flash that up here in a second. And the reason why that happens is when you connect to a network, your computer sends a request to a known location. Like Microsoft hosts a server whose sole purpose is to send a code back saying yes, the internet's available. Or hi, you end up on a page like this, which looks scary, but this is just HTML code. I did this with ChatGPT's help. That's why it looks so uh, fake, unauthentic. I don't know. I wanted a quick tutorial to show y'all how these captive portals work. And this is common uses for this are like Wi-Fi provisioning. Like if whoever has the Wi-Fi network expects you to sign into an account, or the person in mind that I was doing this video for. Like let's say you have a microcontroller and you're going to make a product to sell to users. Well, a typical user is not going to know how to plug that into the computer, get the proper driver for the computer to even recognize it, and then get into it and mess with something that's called a settings.toml file. And they would have to manually input their SSID like I'm doing here and then their password. But this is one of the benefits of ESP32 boards and MicroPython, that this DNS hijacking, which is what happened here to bring us to this page, is possible out of the box. So back to the whole when you connect to the internet and it sends a request to a server. Well, so what happened here is my computer connected to this ESP board sent that request, and the ESP board intercepted it and basically said, "Come talk to me first." It said, "Oh yeah, the content that you're looking for is right here," and my computer recognized that it wasn't a wide open access to that server, so that's what triggers the browser to open. The same thing would have happened on an Android, or I'm assuming a Mac. I haven't done much Apple programming, but so we go on and provision our Wi-Fi here. Now my board just flashed 10 times blue as part of the programming to let us know that it was doing some data, and as part of the programming also, it went ahead and closed that server because those are resource hungry and we don't need it anymore. And now currently the LED is lit up solid green. Ooh, an Unhandled exception occurred. But why though? Ah, okay. Well, look, we will look into that in a minute because it was working just fine. Go figure. I would start shooting video and then it would do something haywire again. Starting post provision server. All right, yeah, let's go on and check if it actually was able to successfully connect to the internet. Something I programmed this to do is to host another server upon successful connection. Let's make sure we're actually back on the internet. So we're back on the internet, and it's not wanting to load that. So I will check this and I'll be right back.
A few moments later.
All right, I think I figured it out. It was a classic pitfall of closing one port down and then immediately trying to reuse that. Even if you include the code that theoretically should allow that immediate reuse, sometimes it doesn't. So we're going to try a different trick this time together. See how it goes. Okay, the board's flashing, so it took that. Should close this. And the board's already connected to the network. So let's see what our console output is now. Yeah, so that port cannot be immediately reused that fast. Like, I'm sure you could probably add a delay if you wanted to, but what I ended up working through was just adding code that if it's not available, then fall back and use the different port. And the way that we're going to open that is just by, if I understand correctly, doing that. Yep, there you go. So the ESP is connected to my home network now, and as you can see, my computer by default went back to that as well. So, and I'll show you all the HTML code for this too. It'll all be in the GitHub. But let's go through the code now and take a look. I'll show y'all all this beautiful stuff and how it works. Where do we want to start? I actually created the access. Oh, okay, yeah. Um, I created the access point file first because it was simple, and so this is telling the board to act as a access point. I mean, as a Wi-Fi router, basically. This is what allows the computer, phone, whatever, to be able to see the ESP32 board available under network devices when you look for a network. BootPy, this is a MicroPython thing. You can turn on WebRipple if you want to be able to view the debugging remotely on the network. I don't mess with this personally. So the next one I crafted was this DNS hijack Python file. So I think I explained it in the first part. I don't know. I've shot this video so many times and I'm running very low on sleep today. But just in case I didn't, you you send a packet to the network to a known source, and DNS resolving basically will it'll take your IP address, resolve it to an address, get you to that place. So what we do here is, and I did use Copilot to help me write this file because there's some complex stuff going on here. I will be straight up honest. There's no way I could have done this in a day without the help of some AI. You would have to read probably several networking books to get a good understanding of it. So here's the IP address for the captive portal and the DNS port. I did this because at one point in time we were showing that we were running out of memory. And microcontrollers are small, so it didn't really surprise me if that would have been the problem. So I done that just to have it skip requests that were over what we're expecting for this example. And that was the same reason for the maximum packet size as well. Also refactored this class to use a variable for if it's running or not. That way we could trigger a function that we define to shut it down. Because these things are very resource intensive. But basically, this guy right here is going to, it opens a socket, and we print at the console to let us know it started. This was the memory stuff to keep it from giving me that error. It's a huge pain in the butt. We build our DNS response, and I'll show you that here in a second. And then we're going to send that response to the address, and here's another. I gave it a minute or a second of delay just to try to fix an issue I was having. And apparently in MicroPython, the garbage collection is not automatic. So that's what all these import GC and gc.collect is. I'm telling it to pick up the trash and free up my heap. That way we don't crash again and encounter all kinds of annoying errors. And then I put some tags here so we could try to go back through the console and figure out where our problem was if necessary. I didn't have too many problems here though. The only time I was seeing DNS server errors was when we were I programmed it to close that server and I was still trying to post to that port somewhere else in code. So that was obviously a problem. But here's the complex stuff I was talking about. We build a DNS response, and that will redirect the user that was trying to go somewhere to the given IP. The arguments are the request, which is a raw DNS request packet from the client, the IP, which is the address to redirect all the queries to. So this is going to be our captive portal IP. And this is where Copilot can be very helpful because it built all this without me having to one at a time go through these things. But I guess if you want to learn about DNS headers, Google's a thing, Copilot's a thing, it'll tell you more about it. But either way, we're building our packet here. And then that's where it's returned all together. The DNS header, the query, and then the answer where we're slipping in where we want it to go to. And then here's that stop DNS server hook that I was talking about. And you'll see that printed to the console. Next one. Okay. I don't know why you're telling me that. No, we opened it before. Okay, all right, yeah, we opened it before. You gotta right click. You can't just double click. Durka durka. Um, Here is the captive portals HTML code, and I use Copilot to generate this because I have never even tried to learn HTML. Like I get it, it's not complicated, but for me, on a tight schedule, this was the easy way to do it. There's the text and stuff you'll see on the actual captive portal page. We give her a spin. The way to get this on the board is to create a new file and then just whatever you want to call it .html, and that'll open up a new window. So then you'll just copy and paste your code from Copilot, or if you want to hack this all out by hand, honestly, the best way I would know of to get it done is Visual Studio Code right here because it'll support that HTML and you can right click and launch the server to view it instantly. So it's pretty convenient. Before I show you main, I want to show you the web server one. I refactored this one a few times as well. It's got a tag for if it's running, so we can stop it in the same way that we stop the other server. This URE. The reason why I imported this is because if you have a password and it has a symbol and you're submitting that through a URL, then it's not going to come straight over as like your symbol. Like it's going to be encoded. So then when you take that and try to submit that to your Wi-Fi password, that's going to cause a problem because it's not expecting an encoded answer. It's just straight up expecting your password. So my solution to that was to bring this in here, the MicroPython version of regex, and then I'll show y'all down through here where we're decoding that. But there's our stop one. Here's our load one to load this from a file rather than just having raw HTML code like spattered all through here. I figured that would be a much cleaner way. And it allowed for me to be able to have multiple HTML files and I could have made this function modular and reused it if necessary, but This is where we're decoding it. You have to do it manually. That'll make sure that, if you use I wouldn't use the percent symbol, but if you use like an exclamation point or an ampersand or something like that, then it'll make sure we're storing it properly and using it properly. Here's where we're saving it to a file, and you don't have to create this file in advance. On the first run of the board, if you saw in the first video, that wasn't there, but after I, went through the flow the first time and then stopped Thawny, now you see it. So it's created for you thanks to this. And the password is not hashed, it's stored as is. So not ideal for a production setup, but for this tutorial, not bad. Here's where we're starting let me make sure I'm not lying to you. No. Oh, yep, I'm about to lie to you. This is where we're starting the server for the provisioning. And that's what I was talking about where I said, immediately be able to reuse that socket, only allow one connection, bound on port 80. It didn't matter. Actually, it allows 5 connections. But no, it did not listen to that reuse address. But I'll show you where I already glanced over where we fixed that. And we're the web server for the provisioning. So if post includes provision in that request, that's why we're parsing it. Okay. It's all coming together. If it includes that, then we know that this is what we were expecting, the provision. It's going to call the callback, extract the SSID and password out of that, give it to the callback, and then y'all will see that in main here in a minute, where that's actually called and used. Yeah, so we clean that up. If you just print all errors right here instead of the specific OS error, it will constantly like however many seconds it takes to run this loop, it will constantly be printing garbage down here. So do it like this, and it'll pick up the socket error when there is one. Like I found one in debugging when I was attempting to use the socket after it was already closed. So that was a good example. But I'm not going back through that turmoil because it took a lot of refactoring this code to get this example to work the way I wanted it to. And then this is the successful connection, the success.html. I'll show you. Oh my gosh, we just went through this. Why did I do this to myself? I'll show y'all it as well. And it'll be uploaded as well, so y'all can have it if you want to. If not, it probably took me 5 minutes. I don't even think Yeah, I don't even think I previewed this one. I think I just told ChatGPT to cook it up and was like, all right, it looks good enough. We'll throw it in there. So let's go over main now. I just hate having all these open, and you can close others, but oh god, what have we done? Try to be on it, yeah. That's weird. I won't show off y'all's features if they won't work. Um, so where these are broken in individual individual Python files. This is how you would call those in and use them. And I know I should have used a cohesive, consecutive. I should have used a naming pattern. I shouldn't have used a different one for each. But thankfully with Thonny, you can see them right there, so it's not a big deal. Just make sure you're trying to import what the file is actually named and not something else. You're gonna have a bad time. Okay? Okay. Here's where we configure just some timeouts. That way it doesn't just run in an endless loop if it wasn't to work. There's where the file has a name, and that way you don't have to type it multiple times. Oh yeah, I was talking before in the other video that I'd already had a password on the access point. So this is how you can do that. Just set it in your config. That way it's all in a global place. So with the ESP32S3 boards, I always use NeoPixel. It's pin 48 on my board. There's only one of them. That was probably not necessary. I think that one actually does it, but I've just left that. I thankfully have never seen that and hope I never do. The function to set the color, to pulse it if you wanted to just, steady on, steady off. Um, so we're gonna have it blue pulsing while it's actively connecting. Solid green as it is right now if it's connected. Well, it's not connected right now, but that's the state I froze it in. The status error. Oh, and I guess while I'm talking, I can go in and restart it. And I'll show you what happens when we do have a file already in place. So it blinked blue. It is sitting on red right now, and it just flipped to green. And this time, because the captive portal didn't have to hog port 80, the STA server was able to have it first go. But I don't know. Nope, that's what I thought. So if you're on port 80, you don't have that on there. There it is. Same, same. Where was I? So the colors, though, this is just good programming practice to define your functions and have it clearly separated where it's very readable. This will facilitate loading the credentials from the file if it exists. That's why we put everything in try-catch loops or try-catch brackets. That way, if it doesn't, exist, then there you go, no saved credential file. Or if there's a problem, then failed to load it. Maybe you had like the wrong name because you didn't use a variable. Who knows? We're not going to have that problem though. So connect to Wi-Fi. This is in the case that that file exists with the correct SSID and password with the timeout. This is just for the LEDs, the connecting. Station is access point is where you connect to it like a router. Station station mode is when it connects to a Wi-Fi network that already exists, which is what my Adafruit user that we were talking on comments was talking about, that he wants to make a way for his users to be able to connect to an existing network without having to do anything super complicated. So This is where we allow people to connect to the board. This is where we're telling the board to connect to an existing network. And then right off the bat, I'm setting both of those to false just to make sure everything is like not running from any previous iterations before we go through our flow. We don't want to have any issues. The We'll set the station to active. We'll attempt to connect with the password. If it's connected, then great. That's where we're printing our IP addresses and stuff. Right here, return true. Otherwise, it failed. So go on and disconnect that. Return an error with the lights, and return this function as false. The provisioning flow. This was a pretty good little function to write. So this enables the access point mode, starts the DNS hijack, and the server for the captive portal. It's an LED. And honestly, I probably could have done this a different way so that all these things weren't broke up into individual functions. This probably could have all been done in main, but I decided to leave it like this to have it modular. You'll see why when I get to main, because main is very small, where all these functions are self-contained pretty much. We do this in a new thread because that is a blocking thing. So you wouldn't be able to do multiple things at once unless you broke into new threads. Good thing about the ESP boards, they have multiple cores, so that is not an issue. Unless it is, and then, we'll see it printed to the console. But I didn't run into any issues. Hopefully you won't either. Here's where we're calling web server, the actual web server file, and we're calling that start HTTP function in that file, giving it the callback. Provision and connect. So if you have the password and if it's successful, then we're going to trigger this unsuccessful connection hook, which is down here. That's not a hook, it's a call to a function. Um, Otherwise, then submitted creds failed, and it's going to reopen that portal to give you another chance to input the correct credentials and overwrite the existing ones. And then our function to shut the captive portal down. And all of these hooks are in each of those files. These two hooks. I don't know why I'm saying it like that. DNS hijack. Stop DNS server. Go. Oh yeah, I'm running it again. Never mind. Y'all should have seen that earlier. That's that stop DNS server hook, and then the stop HTTP one to trigger both of those to happen, and then we garbage collect again here just to make sure we're getting everything. Probably excessive, but man, the debugging problems I had with this. On a successful connection, shut down the captive portal, print that we're starting the provisioning server down here. Yeah, starting post provisioning server. And do that in a new thread because it could be blocking as well. And like I said with main, look at that tiny little main because everything is being self-contained up here. Our logic is look for the credentials. If they're there, then found saved creds for that SSID trying to connect. If it connects, then do the unsuccessful connection function up here, which starts that server and break out. Otherwise, it didn't, so start provisioning, and there's the other function. And then this was just added to get it to stop printing that error whenever you hit the stop button. But all right, I think that concludes this tutorial. I definitely made it long like usual. If you guys or gals have any questions, feel free to leave them in the comments. Please like, subscribe, and share. I'm really trying to get this channel going. And, like my Adafruit guy that wrote in, I am always open to trying to help y'all with technical problems. I wanted to show him just what a captive portal would look like in MicroPython, but I'm thinking about setting up something similar in CircuitPython. The only problem is with those boards, you're limited by you have to talk to that ASP on that board through SPI. Like, it's not the main processor, it's a peripheral. And with a configuration like that, CircuitPython has nothing in place for the DNS hijacking. And I reckon I've read that it could potentially be possible to fork CircuitPython and modify it, but you would also have to find a way to modify the firmware on that peripheral SP32 in order to like set the hooks up and stuff and make the magical stuff happen. Because if you could program that ESP32 to do all the DNS hijacking and the other socket server stuff that we've set up, then there's no reason why you couldn't send it a command over SPI to make that happen. I don't know what you would do out of the box. But that doesn't mean that all hope is lost. From what I do understand, CircuitPython allows serving the HTML over the SPI through that ESP32. So I may, in the future, near future, attempt a CircuitPython. Uh, it won't be a captive portal because I don't know how you would make it do the DNS hijacking, but we'll do a CircuitPython Wi-Fi provisioning page, and there are some clean options to getting users to that. Like you could include it in a book, or if you want to be really sleek with it, then I'd say a QR code with an instruction page would probably be the way to go. But everybody, thanks for tuning in. Hope y'all enjoyed it. Let me know what else I can create for y'all. Peace.